everybody, welcome to another of Mrs. John's class, and today's lesson is about beats. It's a really short lesson. This is a phenomenon that has to do with interference, and you hear beats, which are the alternating pulsing of loud and soft sounds. One of the easiest way to demonstrate beats is by using a set of tuning forks whose frequencies are very similar but not identical. So here I have two tuning forks, and I'll just do one at a time. So these are called the prongs of the tuning fork, and every tuning fork has its own particular frequency and different frequencies of tuning forks. The shape is the same, but they might be thinner, fatter, thicker, different materials. And these are the only instrument that produces pure sounds. Anything else will have overtones in them. These tuning forks don't have those. So that's the sound produced by a tuning fork. Okay, now what happens if I sound two tuning forks together at the same time? Stop that so that you can see them properly. So I've got a second tuning fork which I have weighted over here, making its frequency slightly different to the other one. Watch what happens when I sound them both together at the same time. I'm hoping you could hear the alternating pulsing of loud and soft sounds. If I change the frequency so they're further apart, there are more beats. Okay? So the alternating loud and pulsing of loud and soft sounds are called beats. And how can you calculate the number of beats you hear per second? That's called the beat frequency. So the beat frequency is given by FB, beat frequency. This is an absolute value. In other words, it can never be negative. So it's the bigger frequency minus the smaller one. So for example, if the frequency of one of them was 256 hertz and the other one was 254 hertz, so slightly different, so your beat frequency would be 2 hertz. Okay? So that's how many times the pulsing happens in 1 second. However, the tone that you hear is actually an average of the two frequencies. So the resultant frequency is 256 plus 254 divided by 2. So the tone that you hear is 255 hertz. And I hope that helps. Bye for now.